camera lens. Are you there? Am I all right? Okay, now come down here. Okay, more slowly than that. Okay? All right, I'll give you direction too. Okay? All right. Okay. All right. Tell me when you're ready. Are you filming?
Yeah, I've been filming the whole time.
You've been filming the whole time? Okay. Come up here then. Okay, now what we're going to do today, we're going to do a lab, and we're going to keep it simple. We're going to simply determine the heat of solution of sodium hydroxide. I was about to say solubility, so I kind of changed lanes there, and it kind of came out wrong. Heat of solution of sodium hydroxide. So in other words, the heat of dissolving. When I dissolve sodium hydroxide in water, it's going to be either exothermic or endothermic, and you're going to have to decide that. So let me just go through the lab just very quickly in order for you to perform this lab as accurately as you can. Okay, now, come on down here. Okay, now you'll see here's the sodium hydroxide, which I will give you. You don't touch this, okay? We have a graduated cylinder, okay? We have a graduated cylinder. We have a styrofoam cup, okay? We have a beaker, 100 milliliter beaker. We have some, can you read that? Deionized H2O, right there. Deionized H2O. You don't use tap water. What's tap water? Is that a colloquial thing? Yeah, right out of the sink, out of the faucet, okay? We have the graduated cylinder, graduated, okay? The beaker. We have a balance that you're going to want to turn on. And make sure that the balance is on the desk. Take it off the tray. See the tray? The tray isn't flat, it's bowed. So you want to make sure that a balance is on a flat, solid surface. And you always make sure that it's zeroed before you start. Okay? Now I'm going to do this lab, just very briefly, as if I were you, a chemistry student. Okay, let's come up top. Okay, so the first thing I want to do is I want to take some water. And I want to just over between the 25 and the 50 mil mark. Okay? And I want to put some water in there. Okay? Easy?
Yeah.
Okay? And then I want to take the graduated cylinder. Okay? Now I want to fill that graduated cylinder somewhere between 20 and 25 milliliters. Okay, do you see that? Above my finger? Can you get that? You have that? Okay. So I'm going to take this. I cannot use this to measure volume. I can use that to measure approximate volume. But that's not accurate. Clear? Nor is it precise. So I'll take this and I will. So do you see how I filled that somewhere less than 25 but around so I can actually read it? So then what I'll do is I'll put it on a flat surface, come down, right, and read it. But since I'm old and have a hard time squatting, I'm going to do something that you never do. Don't hold it like this because you don't know if it's level, right? But I'm going to do that, okay? And this is going to be the 10th place, and that's going to be 22.5 milliliters, okay? I'll put that down. Then I'm going to put this thermometer in here. And I need to find the temperature of the water, the initial temperature of the water. And I'm just going to leave this in here for a moment, okay? And I want to make sure that it equilibrates, okay? So I'll just leave that alone for a second. Styrofoam cup, it must be dry. It's got to be dry. If it's not dry, go dry it. Understood? You put it on the balance. Now you'll see that the balance reads about 2 grams. Okay? It's going to read about 2 grams. Yes? Do not press the tare. Just leave it at 2 grams. You're going to write that down. And you're going to say the mass of the empty, dry styrofoam cup is 2.1 grams in this case. Clear? Okay. Now, let's go back to this water here for a moment. This water says, you read to 10th place, this water says 21 0.1 degrees Celsius. Okay? Paper towels. Maybe you have a paper towel, please. Okay, do you get that? Okay, give me 2 paper towels. Okay? This paper towel is for plain water. You put that on the right. Okay? This paper towel is for the solution of sodium hydroxide. You want to put that on the left. Understood? Plain water on the right. Solution on the left. Okay. You'll take this out. We did the temperature thing, right? Take it out. Put it on the table. Wipe it. Dry. Clear? Put that back. Okay, now. Put it on the right. Clear? Okay, now. Is there a problem with the volume of this now? What did I wipe off that thermometer?
The water.
Water, so there's less water in here now, right? So you got to double check. Aha. 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 22.4 milliliters. So now that's your starting volume. Clear? Okay, now. Now you're ready. I come around with it. This is called a spatula. It's called a spatula. And sodium hydroxide. And I put a scoop into the cup. Yes? And in that cup, it's going to say, it's going to give you a larger mass reading. So then you write down mass of styrofoam cup
Plus.
and sodium hydroxide. Okay, good. Then you take your known volume and you pour it in to the sodium hydroxide. It's going to dissolve. It's very soluble. Clear? I take my thermometer, stir it gently, not crazy like you're making a cake, and you're going to dissolve it. And you'll be able to hear it clicking. When it's all dissolved, you find the temperature. And when it stops increasing, when it reaches a thermal equilibrium, then you find the temperature. And you'll find that it might rise 20 degrees Celsius, depending on how much sodium hydroxide I give to you. Clear? Yes? Yes?
It'll start to smoke or anything.
No, it won't smoke. It's just, no. It's not going to boil or anything like that.
Okay.
Okay? So then now what do? I'm done. I took the temperature. Now I have this incredibly corrosive material on the thermometer. What do?
Wipe it off.
I wipe it off with the left. There's not much there. There's not much there. I go over to the faucet and I rinse it. I take the water paper towel and I dry it. Put it back. I take the cup. I go to the bottom of the sink and I gently pour it down the drain. Clear? And then what I do is, the water will be on. You don't want to have the water on fast because then it'll splash back. At the bottom of the sink, you gently rinse the cup with the water. Clear?
Can you throw away the cup or?
No, you don't throw away the cup. Then you take another paper towel please. You take another paper towel. When the cup is completely rinsed and free of sodium hydroxide, you dry it completely. Clear? And then you put everything away. Okay? This is actually empty, right? Okay? I keep this, put the balance away. Beaker. Never pour chemicals back into the chemical loop. This is deionized water. This is deionized water. This is used. You never pour a chemical back in, right? Water can be a chemical. It's not just water from the sink. This is treated water. Yes? So you never put it back. You throw it out. Clear? Then you dry it. Clear? We're done. Question?
Is deionized water, what's the difference between deionized water and tap water?
Water generally doesn't conduct electricity. It doesn't conduct electricity. Pure H2O. What conducts electricity is the material that's dissolved in the water. The salts. Fluorine salts, chlorine salts, whatever salts. Okay? And those salts have to be taken out. So I put the water in the other room, goes through a resin filter. And what it does is it takes out the ions that are in the water. And it produces ion-free water. It's not perfect. You could also distill it if you want to, but this is a quick way to do it. We also have a distiller. You could have distilled deionized water if you really need pure water. Clear? All right, are we done?
Yeah.
End of movie.